Hello student, today I am going to teach you about the Boyer-Murray algorithms. Uh, the rest of the algorithm that we have studied, like the Rabenkorp algorithm and the Nuss-Morris-Press algorithm and the Naive algorithms, are all the string matching algorithm. But among all these algorithms, the Boyer-Murray algorithm is the most efficient one. Why it is most efficient? It is because it uses a function called last function, with help of which it can rule out many of the possible positions of match, and it processes the fast in the fastest way. So, to understand the Boyer-Murray algorithm, I am first going to write the algorithm, and I shall explain you about the algorithm. Then I shall take one example, and with that of help examination, I shall show you how does it work. So first, I am going to write the algorithm. Algo one for then else. Right? Uh, this algorithm is very simple, and you can understand this algo in just two steps. Here, first we initialize two variables I and j. I is equals to m is the length of the pattern string. Suppose we are taking a length pattern of length 5, then the length would be equals to 5. I is equals to m minus 1 and j equals to m minus 1. So initially the both the I and j would be equals to m minus 1 because we are starting the indexing with value 0. So index will start from 0, so the total number I will be equals to m minus 1, and similarly the j would also be equals to m minus 1. After that, what we shall do, we shall start comparing the pj component, element with the ti element, where t is the given text in which we have to find out the pattern p. So corresponding to the ti, we shall check if pj is equal, are same or not. If they are same, and if j is equals to 0, means we are at the index position 0, then we return that at position number I match occurs, match found, match found. Okay, and this is the condition of match when pj equals to pi and we have reached up to the starting of the index. Because we are starting in this algorithm, we first match the last element, then the next one, then the next one, and we keep on till we reach up to the j is equals to 0, means the full pattern of the has been matched. Then we declare that the position number I, we have found the match. Otherwise, if there is no match between the element pj and ti, This was the condition. In else condition, when this match fails, then what we do, we reduce, then, and ij is not equals to 0. If pi equals to, if pj is equals to ti but j is not equals to 0, means only one element has been matched or two element has been matched but not all the element has been matched, then we deduct the value of I by 1 and j by 1, and after that, and if the match does not occur, this is the condition of match, and this is the condition for no match. In this, when match does not occur, then what we do, we find out the new value of I is equal to I plus m minus minimum of j comma 1 plus last ti. I shall define you what is actually last ti. Last ti function is actually the, from right hand side, what is the index, maximum index, that at that position that alphabet exists. I am just after this algo, I shall explain you what is actually the last ti function. Last ti function, suppose a string is like this: A, B, C, D, A, D. Here, the last of in I indexing is like that: 0, 1, 2, 3, 4, 5. Now, the last of A would be from the right, the highest from the right hand side. What is the index at that, at which that element is found, is equals to 4. Now a is existing at element index number 4 and 0 also, but from the right hand side the first index that at which the a can be found is 4, so the last a would be equals to 4. Similarly, the last b would be equals to 3. Okay, so here the last c is equals to c is equals to 2. So this is the last function. So when there is a match and j is equals to 0, then we declare that return is found at the position number I, and if pij is equals to ti but j is not equals to 0, then we keep on reducing the value of I is equals to I minus 1 and j is equals to j minus 1. And if Pj is not equals to Ti, in that situation we use a formula to recompute the value of I. But J remain fixed. Here J will remain fixed, that equals to m minus 1, but I value keep on updating by the formula I is equals to I plus m. I plus m minus minimum of j comma 1 plus last Ti. For example, we have not found a match for the element I, Ti element, then we compute the position of last Ti, 1 plus last Ti, and J. The position of J, we compare between J and 1 plus last Ti, and among these two values, which one will be the maximum will be deducted from I plus M. So, and J will remain constant, that will be same for the rest of the expression, J is equal to M minus 1. If while traversing through the text, if it happens that I becomes greater than n minus 1, I or reaches up to the length of the text, then we declare that the no substring in T is same as the given pattern, and we declare that there is no match found. So the Boer-Moore algorithm is a very simple algorithm. We start the variable I is equals to m minus 1, j is equals to n minus 1. If the match is found and j is equals to 0, then we declare that at position number I there is a match. If there is j is equals to ti but j is not equals to 0, in that situation I is deducted by a value, j is deducted by one value, and if match is not found, that we calculate the value I is equal to I plus m minus minimum of j comma 1 plus last of ti, and j would be equals to m minus 1. So that's all about the Boer-Moore algorithm. This is the most efficient string matching algorithm. So after this I am going to take an example, and with that example it will be much clearer to you. In the given question, this is This may appear lengthy, but it is very easy question. Suppose the string is A B A C A A B A D C A B A C A A B B. This is the given text string. And this may appear a little bit longer, but once you understand the step, it would be very easy. Okay, so it is a 24-bit string, and this is the text, and now the pattern is uh, A B A C A B. Its index is 0, 1, 2, 3, 4, and 5. So this is the P is represented with the index J, and T is I variable. So first of all, according to the algorithm, we shall initialize the two variables I and J, right? I would be equals to m minus 1 and J would be equals to m minus 1. Here the length of the string is equals to 6, 336, length is 6. So the value would be equals to 6 minus 1 is equals to 5 and 5, right? Now after that there are simple steps. Pj, we shall compare. After this, m is the length of the string. Here we will m is the length of the string, not the last index. So m would be equals to 6, not 5. Okay. Now we shall compare that pj is equals to ti or not. Pj and ti. Pj, P5 and T5, right? P5 is equals to A and T5 is equals to, sorry, P5 is equals to B and T5 is equals to A. No match. When there is no match, we shall use the formula. Compute the I is equal to I plus M minus minimum of J comma 1 plus last Ti. This is the formula. When there is no match, then in this situation I is equals to 5, M is equals to 6, and minimum of J is equals to 5 and 1 plus last Ti. Last Ti, for the last Ti we shall write the A, B, C. These are the three alphabet in this string only, A, B, C. So the last function, last of particular would be here. We can see that in this given pattern, the B last is equals to 5 and the last A is equals to 4 and last C is equals to 3. There are only three alphabet, right? So if any alphabet does not occur in the pattern, then we place the last value is equals to -1. Suppose there is a variable d which does not exist in the given pattern, then its last ti would be equals to -1. So here the last ti is equals to at the position last ti means last of ti is equals to 5. So last of 5, right? So that would be equals to 11 minus minimum of 5 comma 1 plus last of T5. T5 element is equals to A. So last of A is equals to 4. So that would be equals to 11 minus minimum of 5 comma 5. So in this case, in this case, the last of it will be 11 minus 5, minimum of 5 is equal to 5, so that would be equals to 6, right? So the next value of I would be 6 and j would be equals to m minus 1, means that will remain 6 minus 1 and 5. So j value will remain same in case of not match, but I value will keep on updating if match does not occur. So the new value of I is equals to 6 and j is equals to 5. So we shall compare the same whether they match or not. So here the new value I is equals to 6 and j is equals to 5. So we shall check that whether the two values are matching or not. So now the new value is equals to I is equals to 6 and j is equals to 5. I am rubbing this part. Now we shall again compare the Ti with Pj. J is equals to 5, P5 and Ti is equals to T6. T6. T6 is equals to B and P5. P5 is equals to B. So match. But J is not equals to 0. J is not equals to 0. So in this situation there is a match between these two elements, but J is not equals to 0. So I and J value would be deducted by a value of 1. So I would be equals to I minus 1, means I was 6, 6 minus 1, 5. And J would be equals to J minus 1 equals to 5 minus 1. So that would be 4. So the new set of value would be I is equals to 5 and J is equals to 4. Now we shall compare that whether these two values are same or not. So when we compare that T I is equals to 5 and J is equal to 4. Now I is equals to 5 and J is equals to 4. We shall compare. I am just marking initially the I was 5 and J was 5, right? Now this value, for this value, Ti would be compared with Pj. So I is equals to 5 and J is equals to P4. And now T5 is equals to A, T5 is equals to A and P4. P4 is equals to A. And match. There is a match, but J is not equals to 0. So I is equals to I minus 1 and J is equals to J minus 1. So new value of I would be equals to I was 5, 5 minus 1, 4 and J is equals to 4 minus 1 means 3, right? So the new value would be equals to I is equals to 4 and J is equals to 3. Okay, now we shall check the condition of match or mismatch. Actually here what we are doing, if the string keep on matching till we reach the end of the pattern, we shall declare the match. If for matching of the pattern, all the alphabets should match. So here we can see that we have found the match position here, we have found the match position here, and we have found the match position here. And J value is decreasing one by one till the position when the match keep on occurring and the value of J becomes 0, then we declare that the final match has been found. But if at any place, if a string match partially, we cannot declare that we have found the match. So now we shall find out that whether for this position we are getting the match or not. Now that T4 and Ti and Pj. So I is equals to 4 and j is equals to 3. So T4 is equals to A and P3 is equals to C. Uh, Unfortunately, here there is no match. So there is no complete match. So no match. So in case of no match, we shall use the formula. So in this case, there is no match. So we shall use the formula. Compute the value of I is equals to I plus M minus minimum of j comma 1 plus last of ti is equals to I is equals to 4 here. 4 M would remain same. M was length of the string will remain 6. Minimum of j here is equals to 3. 3 comma 1 plus last of ti. Last of ti was 4. T4. So that would be equals to 4 plus 6, 10 minus minimum of 3 comma 1 plus last of T4. T4 is equals to A. So and A last is equals to last function is equals to 4. So 1 plus last of A. A is equals to 4 means 1 plus 4. That's equals to 10 minus minimum of 3 comma 5. And minimum of 3 comma 5 is equals to 3. So that would be a new value of I would be equals to 7 and j would be equals to m minus 1 equals to 5. So the new value of I would be equals to 7 and j value would be equals to 5. So I new value would be equals to 7 and j new value would be equals to 5. Right? So we shall check the condition for this position. Now we shall check the value for Ti and Pj. So I is 7 and Pj is equals to 5. T7 position पे आपका number जो exist करता है that is A and the element at position P5 is equals to B. So no match. No match. The formula would be equals to I tends to I plus M minus minimum of J comma 1 plus last Ti, right? So here I is equals to 7, M is equals to 6 minus minimum of J is equals to 5 comma 1 plus last I is equals to 7 means last T7. So that would be equals to 13 minus minimum of 5 comma last T7 at position T7 the element is A. A is equals to 4 हो जाएगा आपका ये 1 plus 4. So 13 minus minimum of 5 comma 5. So 13 minimum of 5 comma 5 would be 5. 13 minus 5 means I would become 8. Means I would become 8 and j would be equals to m minus 1 equals to 6 minus 1 equals to 5. So the new value would be equals to I would be 8 and j would be 5, right? So we shall compute the value for this position. Now Ti and Pj. T of I is equals to 8 and j is equals to 5. Now T8 is equals to D and P5 is equals to B. Again no match. So the formula we are getting again no match condition. So whenever there is a new match condition, then we use the formula, and by this formula we are avoiding some, we are jumping some position, and we are ruling out certain position that match could not be occur at that position. So the formula is equals to I plus m minus minimum of j comma 1 plus last ti, right? So here I is equals to 8, and I is equal to 8, m is will remain 6, and minimum of j is equals to 5 comma 1 plus last ti, I is equals to 8, right? And position number 8, there is an element d, but d element does not exist in the pattern, so we shall place a value minus 1. 1 minus 1 would be 0. So 6 minus minimum of 5 comma 1 minus 1. Here at this position, the element that exists at position number 8 is d, and this number is not existing in the given pattern. Does not exist in the given pattern. When a number does not exist in the given pattern, then we assign a value to the last function, that is minus 1. So we have assigned the value minus 1. 1 minus 1 would become equals to 0. 8 plus 6 minus minimum of 5 comma 0. Now the minimum of 5 comma 0 is 0. So the next position, so in this position, I take 1 second. 8 5. So in this position, the position would be 14 minus 14. Okay, because 14 minus 0 would be equals to 14, right? So the position of j would be equals to m minus 1, that would be equals to 6 minus 1 equals to 5. So the new index would be I is equals to 14 and j is equals to 5, right? Now we shall compute the value for j is equals to 14, I is equal to 14 and j is equals to 5. Now the value T14 and P5. The element at T14 is equals to A, and the position element at position number 5 is equals to B. So no match. No match. So in this situation, what we shall do? We shall reuse the formula I is equals to I plus M. This question may appear to be a little bit lengthy, but this is very simple question because we are using just two formulas. If there is no match, then the formula is I is equal to I plus M minus minimum of minimum of j comma 1 plus last ti, and if match occurs, then we reduce the value of I minus 1 and j minus 1 and we compare the formula again. So this is very simple, but this is little bit lengthy. Okay, so after this we shall compute the value, and the value formula would be, okay, so now the formula would be like this: I tends to I plus M minus minimum of j comma 1 plus last ti, right? The formula is I is equals to 14 plus 6 minus minimum of j is equals to 5. Here j is equals to 5 comma 1 plus last t of I is equal to 14. So T14, T14 is a T at position number T14 there is element A. So last of T14 is would be equals to 4. So that would be equals to 14 plus 6 minus minimum of 5 comma 1 plus 4. So the minimum, this would be equals to 5 plus 6 minus 5. So that would be equals to 15, right? So I would be 15 and j would be equals to m minus 1, means 6 minus 1 equals to 5. So the new value would be equals to I is equals to 15 and j is equals to 5, right? So we shall compute the same for these values. Ti and Pj, T15 and P5. T15, at the position T15 the element is B, and at the position number 5, P5, the element is B. So the match, we have found the match position. Okay, now what we shall do, but J is not equals to 0. Make sure you cannot declare that this is a match situation, because only one alphabet has been matched. So until j does not become equals to 0, we shall reduce the value of I by 1 and j by value 1. So I would be I minus 1 and j would be j minus 1. So this would be equals to I was 15 minus 1 means 14, and j would be equals to 5 minus 1 means 4. Right? Now we shall compare the T14 with P4. At T14, the element is A, and at position number 4, the element is A. So again there is a match. Again there is a match. So here we are getting the second match, but J is not equals to 0. Right? So we shall reduce. Sorry. So I is equals to I minus 1 and j is equals to j minus 1. So the value will reduce. So 14 minus 1 is equals to 13, and this would be equals to 4 minus 1, because the j value was 4. J value was 4 and I value was 14. Right? So 4 minus 1 means 3. Right? So now we shall compare the element for Ti is equals to 13, and so I am rubbing this part. Yeah, I am writing just this part. I is equals to 13 and j is equals to 3. Okay. For T13 and P3, T13 is equals to C and P3 is equals to C. Both are equal, but j is not equals to 0. So what we shall do, I is equals to I minus 1 means 12, 13 minus 1, 12, and j would be equals to j minus 1 equals to 3 minus 1, 2. Now we shall compare T12 with P2. T12 is equals to A and P2 is equals to A. Match, but j is not equals to 0. So in this situation again I is equals to I minus 1 means 12 minus 1 or 11, and j is equals to j minus 1 or 2 minus 1 means 1. Now we shall compare T11 and P1, because this is the value of j and this value of I. At position number T11 the element is B, and at position number 1 the element is B. So both are equal. Match, but j is not equals to 0. Okay, so for the position I am rubbing this part. T is equals to 11 and j is equals to 1. I is equals to 11 and j is equals to 1. And j is not equal. So T11 and J1. Right? So T11 is equals to B and J1 is equals to B. Match, but j is not equals to 0. So now we shall reduce the I is equals to I minus 1 means 11 minus 1 means 10, and j is equals to j minus 1 means 1 minus 1 is equals to 0. Okay, in this situation we shall compare Ti, the T10 is equals to P0. In this situation T10 the element is A, and at element P0 is equals to A. So match and J is equals to 0. This was the condition that we were searching for. In this position, Ti is equals to Pj and J is equal to 0. So we shall return I. I is equals to 10 as the match condition. As the match. ठीक, position I number is equal to 10 as the match, and it means at the position number 10 we have found the match. Okay, and this we can check this, we can verify this question also. um, let's take, suppose we shift at this element, I am rubbing this portion. Suppose I draw this string, place this string at this position, right. Then A, B, A, the string was, and C, A, and B. This is the same match. All the element has been matched. So I is equals to 10. There is match. There is match. Right? So the complexity of this algorithm would be equals to O of sigma m cross n plus sigma of inputs, because OMN plus sigma of input, because there may be other symbols which are not in the pattern but they are in the text. So the complexity would be OMN plus depend upon the extra input that are inside the string. So that's about the Boyer-Moore algorithm. That's very simple algorithm, and it is the most efficient among all the string matching algorithm. I have summarized you in brief. Summarize you that first calculate the last function for the given function. After that, if there is a match condition, then what we do, then and j is equals to 0 when we declare that position number I there is a match. If pi is equals to pj is equal to ti, then we reduce the value of I and j by a value 1. If there is no matching, then we found the value by I is equal to I plus m minus minimum of 1 comma, minimum of j comma 1 plus last ti. So that's very simple. If we reach up to the end of the string, means I is greater than n minus 1, then we declare that the string does not exist in the given string. So that's all about the Boyer-Moore algorithm. Thank you.